one asks 1/2 to the power of 2x plus 1 equals what?
All right, let me write that down, Lily. Let's see. It was 1/2, and then to the 2x plus 1 power is going to equal 1. I'm probably going to need a calculator for this one, but all right. So this is the equation that was asked of us. Thankfully, this one. So this is going to be an equation that we're going to need to use logarithms for. Thankfully, you were with us yesterday. We had quite a tough one that took me almost the whole show to solve, but I did figure it out. This one is not nearly as bad, thankfully. So the idea is this, usually when we're solving algebraic equations, the idea is to isolate the variable. And what we do to isolate the variable is we use our inverse operations. So if our variable has addition, we undo that to get it by itself by subtracting. If it has multiplication, we use division. Now, the issue here is that our variable is actually in the power. So making this what's called an exponential function, like an exponent. The way to find the inverse of an exponential function is what is called a logarithm. It's just basically an inverse opposite way of writing an exponent. So what we do is if anything is written in exponential form, like this, b to the x power is equal to a, we can write it into logarithmic form like this. And the reason why we do that is because when we rewrite it into that form, it rearranges everything enough so that your variable is no longer in a power and it's isolated. From there, we also have one more formula that we're going to be using, and I will explain that in one moment. And that one we'll get to at the end. But so starting out, we basically want to get our equation from this exponential form to the logarithmic form. So really, this is just a matter of kind of pulling apart the pieces of it. The first part, b, is the base. So there's our base. So what I can kind of start out by doing is calling it log of 1/2. That's that base part there. It just moves down to the bottom. Our power, that's another part of it, so this. And what happens is it goes over here, and my equal sign disappeared. Let me get rid of it. And so in this case, our power, it's a lot, but that's okay. So that's going to go on the other side of our equal sign, 2x plus 1. And then this part here, a, answer, it moves over to in front of the logarithm. So that's our 1. So really, it's a lot of rearranging, and I'll color code this so you can just see maybe where the parts go. But that's really all that happens with logarithms is it's rearranging. So then on the left, we have this right here. The way that you would read this is log base 1/2 of 1. And the reason I gave you this formula over here is because that's how we're going to type it into the calculator, is log of a divided by log of b. So I'm going to type in the calculator log of 1 divided by log of 1/2. And you get 0. And then we have 2x plus 1 on this side. And at this point, then we just have to follow our normal rules to isolate x to get it by itself. So we'll subtract 1 from both sides. So negative 1 is equal to 2x, and then we'll divide both sides by 2. So then we end up getting x is equal to negative 1/2. And there you have it. Now, if we were to check our answer, if we would plug, Nathan would do that. He's laughing at me right now. He would check the answer. If we were to do that, what we would do is plug in this negative 1/2 for x into the equation that we originally started with, just to double check that our equation would actually be true.
Can I throw out one more way that it would only work in this case?
Sure.
Obviously, the way that you did it would work every time.
Yes.
But I just rewrote this up here because what I thought, and actually I worked it out the exact same way you did, and then when I was plugging my answer, because it's fun, I thought of this, well, if you
Yep.
remember anything to the power of zero
is equal to 1.
yeah, so this kind of like, if you remember a lot of different properties in math, you can make problems a lot shorter, and you can just say, well, look, anything to the power of 0 is 1, so if this up here that I highlighted in yellow, look, if this is 0, we can write an equation and say, if 2x plus 1 equals 0, then we know it doesn't matter what the base is, it's going
Right.
to be 1. And then we can simply solve and say 2x equals -1,
And
x
get the
equals
same.
-1/2. And,
Mm-hmm.
we have to be
As soon
careful
as I
about-
got 0 on that, I
Yeah.
was like, oh, okay.
That's exactly what I thought as I was
Uh-huh.
going through. And if you just remember those properties, and again, the way you did it and the way I did it initially is the way that would always work.
Yes.
But if you're saying something to the power of something equals 1, you can keep that idea in mind.
Right. It's about knowing your mathematical properties.
Right.
And if you really do understand numbers and understand the mathematical properties, then a lot of times you don't need to go through the steps to solve. You can just kind of intrinsically, oh, well, it has to be that.
It's always a
So-
lot of shortcuts.
That's very true. So 2 ways to solve that problem. Impress your teacher.
Subscribe!
Come on, push the button.
You know
Yeah,
you
you
want
want
to.
to.
Do it.